Welcome to the CS210 video where we're going to discuss the Loader Lab. The first thing you need to do is download the simulator. So you can find that in the files, and there's also a link to this on the Loader Lab itself. And go ahead and download this zip file right here, put it on your desktop or somewhere where you know, and unzip it. Now I've put mine on my desktop and I've unzipped it so I have all of these Java and class files on my desktop. Now you're free to go ahead and poke around the Java code, although you might find it a little complex and certainly not something you have to do. But all you really need to know is that the main method is in this simulator class. So if you've taken 202 and know Java pretty well, you know that this is the class name that we want to use to launch the file. To do that, we're going to need the command prompt or terminal window. Now, hopefully you know a little bit about using a terminal window, but first of all, we need to get our working directory in the same place that our simulator is. And in that case, I want to do a CD and then do desktop. Now, if you press tab after you've typed a few letters, it will complete the rest of the word for you. So CD desktop, that says change directories to my desktop folder. And if you're on a Windows machine, the command should be the same thing. You just got to make sure that you're in your home folder where all your files are, and that inside of that folder, you got the desktop folder. Now, I've unzipped it into the sim folder. So now we can do that. Now, if you're on a Windows machine, the command is dir, which lists out all of your files. On a Mac, it's ls. And so that you should do an ls and see that you got all of your files, all of those class files in your current working directory. Then to run your program, you just type Java tsc simulator, and you can press tab to complete. It might include the .class on there. You do not want to do that. You want to just run it with the TSC simulator. And when you do that, it'll load up your simulator right here. And that is the program that we're going to be working with. Now over here, we can see the 5 registers that the programmer can control. That's the program counter and the 4 general purpose registers. Right here, we have a list of memory. On the left side is the memory address, and you can see that value is in hex. And if you do want to change how something appears, you can actually put it in decimal or binary. And this is whether you interpret the number as unsigned or signed. So we have all of these, all of the numbers that are stored in memory. These are the memory addresses on the left, and on the right are the contents or the numbers that you stored. As you can see, our memory addresses will start at 0000 and go all the way down to the biggest number we can represent in using 16 bits, and that's FFFF. And that's how much memory we have. It's actually quite a lot. So there's quite a lot of storage, at least for our purposes in this class. Over here is the debug console, and it'll show you what instructions it runs and what memory address that instruction is located at. That'll come in very helpful for this view, for this lab. We can also jump to a specific memory location, and we can have a breakpoint. Down here is the I/O console, and this is to get input or output. If we want a program to have somebody input a number, they can turn on the lights. They have to input it in binary, and they can send that data to the computer. And if the computer wants to print out a number, it can print out the number here. And of course, instead of entering it manually, we can store the numbers or read the numbers out from a file, which will be really nice. And right here, these buttons down here are how we program and control our TSC. Now in this Loader Lab, you'll definitely want to open up this programmer's reference and have it available for you to, and this is where you'll get your information on how to convert the assembly instructions into machine code. But first, we'll start out with this TSC simulator tutorial. you can read through it and follow it on your own, but I'll also do a video demonstration of going through this simulator tutorial. So I highly recommend reading through this simulator tutorial as you follow along. Especially pay attention to what a simulator is, and you can read about how it works, but we're going to go ahead and move to this step. For your first program, let's enter the following machine language listings. So we want to enter these two instructions into our simulator. Now, the way we're going to do that is we're going to use the load memory button. Now, the load memory button will take whatever's on these lights and put it into memory. But where in memory? We have a lot of different locations. Well, it's going to use the PC counter as a guide to say where it should go in memory. If you notice in our PC, we have all zeros. So that means at memory address all zeros, if I press this load memory button, whatever is on these lights will go into that memory location. So I'll put the first instruction on the lights right here. And when the light is on or green, then that means that it's a 1. And if it's off, then that's a 0. So this right here is the first instruction that it wants us to program into our computer. Now we could clear everything before we do that, and that just makes sure that our program counter is pointing to memory location 0 and that there's nothing else in memory. And now if I click load memory, we can see that that instruction is right here in this memory location. But you can see that's not right. We wanted to put it in memory location number 4 in our TSC. So in order to start over, we'll just clear everything. And we'll just press this clear, and we're going to clear the registers, but that only clears the registers. It still leaves that instruction in memory. So up in this memory here, we can clear everything and say, yes, now all of our memory has been put back to 0. So next, we want the memory location, we want the number 4 in our program counter, so the instruction will go into memory location number 4. So to do that, we just put 4 on our lights, click load PC, and now you can see that we have the number 4 in our PC counter. Now we can input the first instruction onto the lights. Now we have the first instruction there. Our PC is pointing to memory location number 4, so we can click load memory, and our instruction is now stored in this memory location. Another thing, if you notice, our PC counter has been incremented to the next one. That's really nice so that we can just keep loading our next instruction and it will go into the next memory location. Instead of having to put 5, then load PC, then the instruction that goes in memory location 5, the PC counter increments for us. So let's go ahead and put the second instruction on our lights. And this instruction looks like this right there, and click load memory. And now we have that instruction on our lights right there. And just to be sure we did it right, if we look at our tutorial, we should be able to see F6C0 and F01D at these two memory locations. And sure enough, we do, so we did that right. So now let's go ahead and run these two instructions. We're going to take our PC counter and we're going to point it back to 4. And now that we put 4 in our lights, we're going to click load PC. Our PC counter is pointing at 4. We could go over to this debug console and press step, and we can see that it executed one instruction. And this instruction is the add instruction, and it wants us to add register 1 and register 2 and put the result into register 3. I'll show you where you can look that up later. And then we'll go ahead and click step one more time. And that's the halt instruction that tells our CPU to stop executing the next instructions. So continuing on with our tutorial, it wants us to input some more instructions into the first 4 slots in memory. So this should go in memory location 0, 1, 2, and 3. And then we already inputted instruction 4 and 5 into our memory. So let's go ahead and input these instructions into memory. So to get our PC counter pointing back to 0, 2 options. I can just put 0 on my lights and click load PC, or I can click clear and clear my registers. Notice that doesn't clear memory. So now let's go ahead and input those next instructions into these memory locations right here. So I put the first instruction on my lights and I click load memory and I get the instruction put up there. Now that instruction I just put in happens to be this instruction. Now I'm going to put this instruction in. And notice my PC counter is pointing to memory location number 1. I got the instruction on the lights. I click load memory, and that puts the instruction there. Then the instruction for memory location 2, which is really the third instruction, is now on the lights. I click load memory, and it's in there. And now I got it on the lights. I'm going to click load memory to load it into memory location number 3 again. And now we have all of these instructions in memory. And I'm just going to check to make sure my memory contents is correct. So according to the tutorial, it is correct. So now we need to set our PC to 0 again, and we can press start. So 2 ways to set it to 0. We can put 0 on the lights and click load PC, or I can just press clear. And now my program counter and all of my registers have been zeroed out. I'm going to clear my debug console here, and I'm going to use step this time, and then I'll show you the faster way to run our program. But here's instruction 1, instruction 2, and if you notice, we actually have something in our register, our instruction 3, instruction 4. Now we have something in a register 2, and then we do our add, and if you notice, we have a result in register 3, and then our program stops. So let's go ahead and run that the automatic way. So I'm going to clear my registers. All my registers are at 0, including my program counter is pointing at this instruction right here. So I'll just click start, and you can see it just runs all the instructions until it hits the halt. And in that case, we have the same result in here. So what does this program do? Well, first of all, this is a load high immediate, and I'll show you where you can find all the information about these instructions in a second. But this is the load high immediate into register 1 of 0. So that really just makes sure that 0 is in register 1. And then we're going to add 28, the number 28, to register 1. So this 1C is 28 in hex. If we really want to see that, we can go to register 1 and go to sign decimal, and you could see that it's 28. And then, of course, this zeroes out register 2. And then this adds 36 to register 2. So we should have 36 in register 2. And we can see that value right there. And then we're going to add register 1 and register 2 together and put the result in register 3. So this is 40 in hex, but if we want to convert that to decimal, we can, and we get 64. So 28 plus 36 is 64. Now, if you pay attention to the reading that's on the page with this video, you'll notice that there's a link to the programmer's reference, along with a link in the loader instructions as well to this programmer's reference. This lists out all of our instructions, and if you notice, we did an add immediate instruction, and it shows you the name of the instruction. It tells you that you can put 2 registers and an immediate value. Down here, it has a description of what that instruction does, and then it has this right there. Now, looking at that, that might seem, oh, what does that mean? I don't understand that. Well, there's one more page that you want to look at. And again, in the reading, there's a link to this page. It's called the Register Transfer Language. And it has a little table that tells you what all of those different symbols mean in this operation right here. Now, in this add immediate, what it's saying is it's going to take this immediate value that happens to be 8 bits from 0 to 7. It's going to extend it up to be 16 bits, and it's going to preserve the sign, whether that's a positive or negative number. So once it makes this immediate value, it deletes all of this. It tells it what instruction, what registers to use. And it extends it up to be 16 bits. That's what this part right here is saying. So take bit 0 to 7, concatenate on bit 7 8 times to make it a 16-bit number, add that value to register RS, and store the result into RT. So you can read through this programmer's reference, just kind of a glance through it. Here's the add instruction. It takes register T and register S, adds the result, and stores it in register D. Now you should follow through with the rest of this tutorial. I won't show this on the video, but it wants you to replace the instruction at memory location 5 with this instruction right here. And this happens to be a write word that's going to display a value onto the I/O console. And then it wants you to take the old instruction 5, that happens to be this, and put it in memory location 6. So we're modifying the program, we're inserting one new instruction. When we do that, before the program quits, you'll see this 64 converted to binary will get displayed on these lights, and then this light will turn on, asking you to acknowledge that you've seen that. Because computers are pretty fast, they can go in a loop, and if you're printing something out and you want to see each one, if it goes too fast, it might erase the first one and put the second one before you've even seen the first one. So for that reason, it will pause and wait for you to click this acknowledge data, and then it will continue on. In this case, the next instruction will run will just be halt. So go ahead and try that on your own and make sure that you got that working. After you've inserted that instruction in here and moved the halt down, then what you need to do is make a screencast of that working and you acknowledging the 64 coming out. And that's for your preparation assignment or your engagement assignment to show that you've been watching this video. It's not part of the actual loader lab. But hopefully up to this point, you are now ready to start on the loader lab. You know how to use the TSC simulator well enough to do that. Now, another thing that you might have realized is that programming with those lights on that simulator is going to get really tedious, and you probably don't want to enter more than 5 or 6 instructions in there because it will take way too much time. So now the loader labs, we're going to write this loader lab so that we have a program in memory that will load all of our other programs into memory so we don't have to type them in manually like we will have to for the loader lab. So there's nothing to load the loader into memory. So we are going to we're going to write a program that loads other programs into memory. So one program is going to read other programs out of a file and load them into memory. And you can read through this. This tells you the format of those files that we're going to read in. So the first thing that we read out of the file will tell us how many segments are in the file. And so we could have one segment, 2 segments, or a lot of segments. The second thing that we'll read out of the file will be how many instructions are in the first segment, or words in this case. And words are 16 bits, or something that will fit into one memory location. So that's how many, or this is actually where the first segment should go in memory, how many words are in the first segment, and then we'll have a list of all of those instructions or words that we should put into memory. Then we'll have where the second segment should go, how many words are in the second segment, and all of the instructions in the second segment. So we actually don't really need to know that too much because the loader has already been written for you. So what you need to do, though, is convert it from these assembly instructions into binary. Now, the first thing in this program isn't an instruction to convert at all, neither is the .and. Anything with a period in front of it is just telling the assembler some information. And this is actually an important piece of information because it's telling it where in memory this program should go. And if you notice, we go at FFF5. So why at FFF5? Because this is a program that's used to load other programs into memory. So we're going to put this program at the very end of memory to keep it out of the way so all of our programs can use the beginning of memory to store their instructions. So again, the FFF5 means to put this program at the very end of memory. So if we look here at our memory locations and we go scroll all the way down to the bottom, this is where the first instruction of our loader should go. That means we have to put FFF5, and this is FFF5 on the lights, and click Load PC so that we can load the instructions into memory right here. Then we put the first instruction on these lights, click Load Memory, and it will go right there. And if you really want to count it, there are enough instructions right here to fill up the rest of memory so that this halt instruction, which is the very last instruction, will go in this memory location right here at FFFF, at the very last location in memory. So your loader should fill up from here all the way down to here. So next we have to convert each instruction into ones and zeros. And to do that, we need our programmer's reference. So the first instruction is read word register 3. Now going to our programmer's reference right here, we can scroll down and find the read word instruction right here. Click on it, and you can read about what it does, but again, all you have to do is convert it to the ones and zeros. And here are the ones and zeros that you need to do a read word. So we got 4 ones, then 4 zeros, an RD, and then this number right here. So it's all filled in except for these 2 bits. And those 2 bits, if you notice it says RD right here and RD up here, well, that's the register. And notice I said it was a read word register 3. So we would put the number 3 in these 2 bits. So again, looking at the programmer's reference, we have 4 ones, then 4 zeros, and then we have the number 3. This is the RD bits, these 2 right here. And then I'm just filling in the rest of those numbers. And then of course we can put spaces by 4, but remember those RD bits, those 2 that weren't filled in, that is register 3. So register 3, I put the number 3 right there. So hopefully you can do the rest of these read words. And then I will do this add immediate right here, this instruction right here. So hopefully you can do the rest of these. When I do this, that will show you how you can do this add immediate and the store word as well. So again, in the programmer's reference, I'm going to click on that add immediate. And we have this encoding right here. And now in this one, there's a lot more bits that you need to fill in. So I'm doing the add immediate, register 1, -1. And so the first 4 bits are 0, 1, 0, 0. So that's pretty easy. But then going back, the next bits that we need to fill in, notice it's RT, and notice the first number right there is register 1, and if we match it up, we get RT right here. Now be very careful, because if this were an add immediate, register 2, register 1, notice RT would be 2, and we'd put 2 in 9 and 8, not in here, because this says RT goes here. So it's switched. RT is first here, but it's second here. So make sure you match up the name with the bits. So in this case, again, that should be a 1. But when they are different, like for instance, this one, in this case right here, you want to make sure that you match up the 0 as the first one. But if the 0, if the first one goes here in the spot, it ends up being second. So be really careful about that. So now this is register 1, -1. So RT is 1, so we should put 1 here. RS is 1, so we should put the binary value of 1 here. And then we need to put -1 in our immediate field right here. So I have the 1 for RS right here. And then I have the 1 for RT that matches up with that. And then I put the value 1, but notice it wants the value -1. So what I need to do, if this is +1, we need to put the negative value of 1 in that. So we need to do the 2's complement of +1 in order to get -1 in here. These are signed numbers. So in that case, -1 is actually all 1. So this is -1 in signed binary using 2's complement. So notice in this case, we have +1. So we'd want to keep it positive, which is what I had before. In this case right here, we want 0. We want a -1 there. So that should teach you everything except for what to do with this value and this value. So if you notice, we have branch greater than 0, and we have a register. So notice bits 10 and 11 are RS. And in this case, we're using register 1, so we should fit in 0, 1 for that. Now, what about this address offset? That is what we're going to add to our program counter. So if we add to our program counter, we're going to move our program further down into memory. So if I add, say, 3, then I would move the program counter and jump over these 3 instructions, and I'd actually fall off the end of memory. So I don't want to add a positive number. I want to add a negative number to make our program counter that is pointing at this instruction to move up into memory so that it points at this matching label. Notice we see start and start. So we want to move this guy up to here. Now there is one more trick. When we're executing the instruction, the program counter is actually already pointing to the next instruction. So it's already pointing to this one. So to move it up, we would want to add a -1, 2, 3, 4, 5 to the program counter to get it to point back up to this spot right here. So start, start, but remember the program counter is pointing here and we want it to be negative. So you got to take +5 and take the 2's complement of it so that we can get it to point back up to here. You're going to want to do the same thing for new segment, but remember the program's counter is pointing to here, but you want to move it back up to point up to here. Now you can go ahead and convert all of the rest of these instructions to 1s and 0s. Then you'll have all the 1s and 0s of your instructions to fill into memory right here. And you just input it in memory just like you did earlier in this video so that we put the loader instructions in this location in memory. Now, before you start, you'll probably want to clear everything so that you don't have anything else in memory, like what you the simulator tutorial that you did. So you want to clear everything and then point your program counter to here and then fill in all of your instructions. Before you move on, you want to burn to a ROM. What that means is take all of the data that's in memory and save it into a file. That way, when you quit the simulator and you launch it back up again, you don't want to have to type the loader back into memory. You can just load from a ROM and restore the loader into memory. After you do that, you can follow the instructions to select an input file, and that will load another program into memory. So you point your program counter to FFF5, you select your input file, and you click go, and that will load another program into memory. After the program's loaded into memory, most likely at the beginning of memory, you point your PC counter to the program and click start again to run the program. So you're going to have to click start twice, once to run the loader to load the program into memory, and then again to actually run your program that was loaded into memory. And then after you've done with that, create a video showing that you were able to load a program, the sample file, into memory, and then run the sample file and get the right output. So hopefully you'll have a lot of fun doing this. This is how the very first programs were written. They were written by typing numbers onto a console, loading those numbers into memory, and then having the computer execute those programs. Now this is just to show you exactly what you should do to pass off your project. You should make a video of you doing this. First, you launch your simulator. Now I clear everything. Make sure you show that you cleared everything. Then load from my BROM and select your loader file that you've just saved. Then scroll down to the bottom of your memory to show that the loader is loaded in. Now mine's all grayed out, so you can't just copy from this video, but you should show that you have your loader loaded in. Then you should point your program counter to FFF5. That way we're pointing it to run the instructions inside of the loader. So you click Load PC and we got FFF5. Next, download the binary file from your instructions, and then come up to your file menu and select an input file. This is what you're saying is instead of reading data from the I/O console, read it out of a file. So select your input file and select that binary file that you just downloaded. You can see down here the input source has switched to file, and our program counter is pointing at FFF5, so we can click Start. And you can see that it loaded a program into memory up here, went pretty quick, but we can clear all of our registers, make sure our program counter is pointing to that program that was just been loaded in, and you're going to click Start again to run the program that we loaded in. And you can see that we get 30 in hex, or this in binary. You have to click Acknowledge Data and show that the last instruction was a halt instruction that you ran.